Now, 48, short version. 16 times 3. Square root of 16 is what? 4. Out comes the 4. What's already out there?
I forgot about that.
What's already out there? So now I have two coefficients. What do coefficients do? Multiply 12 root 3.
Yeah, I did it.
16x squared y to the fourth. Well, what's the square root of 16? 4. So out comes 4. How many x's can I get out of there? 1x, because there were 2 under there. How many y's can I get out of there? 2, because there were 2 y's under there. Anything left under there? No. What do I do with all the coefficients? Multiply them. 20x y squared. Because there was y to the fourth under there, which means is y, 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 y. Out comes a root of y, out comes another root of y, y, y. Y times y is y squared. That's y. Okay? What's different on the second row? They're all cubed, which means I'm looking for groups of 3. This one is, of course, 8 times 5. Why did I use 8?
Because it's got a cube root of 2.
Cube root of 2, so out comes a 2. What's already out there?
6 cube.
3, so it is 6 cube root 5.
Yeah, I'm a master at this.
108 is 27 times 4. Why did I choose 27?
Because it's got a root.
Because it's got a cube root. What is it?
3.
3, so out comes a 3. How many x's can I get out of there?
2. 1.
1, which takes up 3 of them, leaving me with how many?
Oh no.
2, because I took out 3 of them. How many y's can I get out? 2. What did I leave? A single y. What's out front? 3xy squared times 2. 6xy squared. Cube root 4x squared y.
Oh yeah, x squared. Did I do x squared? No, I didn't.
Cube root of 16 is 8 times 2. So what comes out?
1.
A 2. And the 8 is taken care of. Why? Because the square root of, or the cube root of 8 is 2. How many x's can come out? 1 of them. So that takes 3 of them out. So he's down to 1. How many y's? 3 of them. So they're all gone. What's left? 6x squared y fourth. Cube root 2x. Can everybody simplify a radical? Yes. Can everybody simplify a radical with variables?
Yes.
Yes. Can everybody simplify a radical with an with a coefficient?
Yes.
Can everybody simplify a radical with a coefficient and variables? Excellent. Violent. Violent. Excellent. All right. I left you with work. I left you with page 123 and 124 and 125. 123 is the cube root of 108. That is the fourth root of 1,296 times 5. So 5,000 and another 1,000 is 6,000. I can't be bothered. 1,296 times 5, which is 1,300 times 5, which is 65, which is 6,480. That is the cube root of 125 times 7, 700, and 175, 875. That doesn't change. It's root 105. That's 14. That is 18 cube root 2. 216 times 2, cube root is 6, 6 times 3. Yes. That one I can't remember in my head, so I break it down. 375 times 10. That's what I would have done first. Yes?
Why do we leave b as 14?
Because the square root of 196 is 14.
Oh, it does have that.
Then I would break that down into 2 and 5. Then I would break that down into 5 and 75. Then I would break that down into 5 and 15, and I would break that down into 5 and 3. And there is my group of 4. So out comes a 5, and I left 6 under there.
Underway.
384 I would break down into 2 and 192, 2 and 96, and then there I would go 16 times 6, and I would see there is a group of 2, and that has a square root, so out would come 2, out would come 4, 6 was already there, and I left a 6 under. 2 times 4 is 8. 8 times 6 is 48, root 6. And finally, 180 is, of course, you break it down however you see fit. Most of you probably went 1810, 2 and 9, 2 and 5, and stopped there, I hope. Because there is a group of 2, so out comes a 2. There is a square root, so out comes a 3. There was already 2 out there, and you left a 5 underneath, and I know that it just died. 2 times 3 is 6. 6 times 2 is 12, root 5, and you need to keep that negative out in front. Now, how did you do 6G? Because I didn't want you to use a calculator. What'd you do? You have 2 options. What is option 1? Starts with an E. Ends with an E. Estimate.
I was going to say expand.
We know that the square root of 2 is a little bit more than 1. A little bit more than 1 times 5 is 5. Right? That's one way you could have done it. Not the best way. The way I would recommend is make them entire radicals. Which means this becomes the square root of 50. Because the 5 squared would go under there. This would become the square root of 48. This would become the square root of 54. This would become the square root of 28. And this would become the square root of 72. And now it's real easy, right? What's the smallest one?
Yeah, but it's not 5. It's 7.07.
The square root of 28, which is this guy. So 2 root 7 is on the farthest left. Then what? 48. Then 4 root 3. Then what?
I don't, that's the
Then 5 root 2, because it's fitty.
no, because the root 2
Then what?
would make it 5.
Then 6 root 2. What's different in H? Can you do the same move? Can you do the same move? For the first 3, right? Because that's the square root of 180. That's the square root of 13 times 4 is 52. That is the square root of 36. But here, cube root 10. Now I have to estimate, don't I?
Kind of, yeah.
Cube root of 180, well, that's obviously the biggest. Cube root of 52 is obviously next. Cube root of 36 is obviously next. Cube root of 10, well, isn't that really close? Approximately the cube root of 8, which is what? So that's just a little bit more than 2. That
0.15.
I know is 6. That I know is a little bit more than 7. So I know that's the littlest one. Cube root 10, root 36, root 52, root 180. Gouda? Great. Turn to page 126, if you would be so kind. Ms. Goot?
You celebrate Pi Day.
No. Pi day should go away because 3.14 is not pi. I know that. I know what you're wondering about.
What do you think about 420 then?
What about it? 420 is a time. A stupid time. Because intelligent timekeepers of the world would use the 24-hour clock.
I know.
But North America can't seem to get their mind around that because then they would have to subtract by 12.
You don't really just have to go 1, 2, 3, 4, 5, and go up to 12 and continue.
But
It makes
yes.
sense.
Of course. It's about that time when bladders fill up. All righty then. Sneak preview of Dad Joke Thursday. Why is a boiled egg the best breakfast? Because it's hard to beat. One more just for fun. Just for fun. I was addicted to soap, but I'm clean now.
But
Not even the slightest bit humorous.
The boiled egg one's good though.
That was a good one.
Yeah. Boiled egg in the morning is hard to beat. Okay. You guys are intelligent young people, as I am constantly reminding you. If I tell you adding and subtracting radicals is very similar to adding and subtracting variables, then you should be okay, right?
Yeah, we can.
If I wanted to add and subtract a variable, what is the rule for that?
Exponent laws, maybe?
What has to be the same?
Oh, the index number must be the same, right? Because it's just like the base
Okay,
fraction.
again, I'm talking about variables now. Do not jump a gun. How do you add variables? What do you know about adding variables?
Oh, there must be the same variable to combine.
They must be the same variable.
Yeah.
So if I were to add x plus x, what would I have? No.
What?
What would I have, Green? 2x.
No way.
If I add 3x plus 7x, what would I have? 10x. If I add 3x squared plus 9x squared, how much would I have? 12x squared. If I add 4x plus 3y, what do I have? I have 4x plus 3y because there's nothing I can do there. Why? What's the rule? Pardon me, Veronica? The variables are different. We can only add variables when they are the same letter and the same what?
Value of a term.
I call your attention to the third of four examples.
It has the same exponent.
Same exponent. All right? To add variables, we must have the same variable and exponent. And then what do? We add what part of it? What did I add here? What did I add here? What did I add here?
A coefficient.
Right. We add the coefficients. So, if that is our basis for understanding how to add radicals, let's see if you can figure it out. What is 3 root 7s plus 7 root 7s? 10 root 7s. Nicely done. Why? Because that is a coefficient times something, and both of those are the same thing. Right? Okay. So what would this be? 3 cube root 9 plus 4 cube root 9. 7 cube root 9s. Everybody good? What about this? 3 root 7 plus 2 cube root 7.
That's already the simplest form.
Can't do anything with it, can you? Why? Cube roots and square roots are not the same thing. Okay? Is everybody good? It's pretty easy. Let's start with some practice and see what happens. What's example 1A? Three root 3. Why? Because there should be a 1 there. So I have 1 root 3 and then 2 more root 3s for a total of 3 root 3s. What's B? 8 root 6. Just say root. Everybody good? How is C different? There's another one there, right? So we already know what to do with that. What do I do? 5 minus 3 minus 4 root 7, which is negative 2 root 7 plus root 2. Because I cannot put them together, can I? Because root 7 is not root 2, is it? No. So what do I got to do with D? What should I do there?
1 minus 2 root 6 plus 1 minus 2 root 3.
So that's 1 minus 2 root 6 plus 1 minus 3 root 3. What's 1 minus 2? Negative root 6 plus, what's 1 minus 3? Negative 2 root 3. How would we write that more tidily for math people purposes? Negative root 6 minus 2 root 3. Can everybody understand the principle behind adding and subtracting radicals? It is not complicated. You know it already, except you know it with x's and y's. Yeah?
Yep.
Yeah. What is my favorite instruction in all math? Simplify, simplify, simplify. When should you simplify? Every single time you can. Right now, are those addable? Why?
They don't have the same.
Starts with an R, ends with an E, has Adican in the middle of it. I know you did. You ruined my joke. They do not have the same radican. So what should I do? Simplify. Why? Because I can. What is the square root of 32? Well, isn't that 16 times 2? Yeah. What is square root of 8? Isn't that 4 times 2? What's the square root of 16? So what comes out? So I have 4 root 2, do I not? What's the square root of 4? 2. So what comes out? 2. What did I leave under there? 2. Now what do you see?
Addable radicals.
Addable radicals. That's fun to say. I have 4 root 2's and I have 2 root 2's. For how many root 2's? 6 root 2. Dun, dun, dun. Jazz hands. In B, can I put them together? No, of course I cannot, because they are unlike terms. So what do I do? I simplify. What is 28? I would use 4 and 7. Why? 4 has a square root. What is 63?
I don't know.
9 and 7, because 9 has a square root. What's 112?
It's 12 and 7. No, it's not.
It's 16 and 7. What's square root of 4? So what comes out? 2 root 7. What's square root of 9? So what comes out? 3 minus 3 root 7. What's square root of 16? So what comes out? Plus 4 root 7. 2 root 7's, take away 3 root 7's, is negative 1 root 7 plus 4, 3 root 7's. Complicated? I think not. Because you all know how to add like terms.
It's like adding fractions.
Hey, wait a minute. That looks a lot like the one we just did.
No, it So there's a C there.
What's different? They just have coefficients. So when we bring out that square root of 4, square root of 9, and square root of 16, what are we going to do? We're going to multiply by those coefficients, aren't we? Go! None of you even know that piece of music. It's the theme music from the TV show in the 60s called I Dream of Jeannie.
Oh, my mom watched.
I Dream of Jeannie was a hilariously funny show. This astronaut lands in the ocean and there's a bottle floating by and he grabs it and he takes it home and in the bottle lives a genie. And then he pretends she's his wife. But she doesn't understand how the world works, so she's always doing magic and stuff. It's hilarious. And it's from the 60s, so it's even doubly funny because it has 60s things in it. Is everybody Gouda? 9 root 7. Ya? Ya. Does anything change mathematically in D? No. Instead of being 4 times 7, what is this? 4 times C.
It's actually easier to do the figures because you don't have to do the factors.
I know you're listening to music, which is probably why you're daily assigned to pack. Would you like another assignment to pack? Then I would suggest changing your behavior. Instead of being 4 times 7, it is now 4 times C. When it was 4 times 7, we took out the root of 4 and we left the 7. So what are we going to do here? He waited patiently. Take out the root of 4 and leave C. 2 root C. What are you going to do here? 9 times C. What are you going to do? 9 times C. Take out the root of 9, which is what's already out there. So what do I do? Minus 12 root C. What's 2 root C's? Take away 12 root C's. Negative 10 root C. Ya? Ya. Uh-oh. Mr. Myers. A question with variables, a question with trigonometry, a question with adding radicals.
Oh my God.
Whew. Why did I put that in capitals? To stop you from doing what?
Simplifying it halfway through the equation. You know? Like
To stop you from using your calculator. Well, how will we ever find the exact value of x?
We've got to use trigonometry.
We got to use trigonometry.
Without a calculator, though, I don't have those ratios memorized. So can't do that.
Really?
Oh, I see.
You don't remember what the ratios are for a 30-degree triangle?
I remember now.
1, 2, root 3, correct? Everybody remember that? Okay. So, this is now 40. So what would that make this? 40.
They can't both be.
What would that make this? 80. Right? So if that's 40, that's 80, correct? And what's this? That's the square root of what? 80 squared minus 40 squared, right? Because you know the hypotenuse, right? That's the square root of 80 squared minus 40 squared, yeah? And we could simplify that, couldn't we? What's this guy over here? If that's 30, what's this? 60. So what's this? Everyone agree? Okay. Which means x is what? 80 squared minus 40 squared plus the root of 60 squared minus 30 squared, right? Okay. Ah!
That's it.
No. Now what could we do? Talk to your neighbor.
Okay. Hello.
What could we do?
Okay. I'm doing
Yep.
it. I'm doing it.
You have lots of options.
I'm simplifying everything. I'm making everything. Uh-oh. I see you, Myers. I see you. Okay, wait a minute. 1, 2, 3, 4, 6, 7. 7 twos.
Would anybody like to share one of the strategies they are trying?
No, I would not. I would really not.
Nobody? There should be no need to go to your calculators.
I'm doing it best I can. I'll share after I'm done.
I don't mind waiting. I got nothing but time.
All right.
Time and coffee. Nope, I'm out of coffee.
We're screwed.
That sounds like a movie line.
How many twos? 1, 2,
You got till I run out of time or I run out of coffee. Uh-oh, I'm out of coffee.
I don't know if I shot that. I didn't put that right. You feel like you punk. Then he doesn't.
Actually, I wouldn't even say it. I would say, you got till I run out of time or till I run out of coffee. Then I just look at him.
What in the name? Okay. So I kind of got an idea.
What would you do, Luke Pearson?
So I got the factors A and the Gives
Now
up
I
40.
know what I
You know, I just did pulled out the 8 and 10, the 4 and 10, 6 and 10, 3 and 10, whatever. So I got 7 twos for 80, 80 40 combined, 7 twos. So that's actually 2 to the 14th power because there's an exponent right there. That's there's 2 80s. So there was also 2 5s left over, so I was 5 to the 4th. So square root of 214, 5 to the 4th for that part, and then square root. For the other one, we did the same thing. I found 2 to the 6th because there were 3 2s altogether. 3 to the 4th because there were 2 3s, but I had to remember that second 2, and same thing with the 5. I had to do 5 to the 4th because there were 2 5s as well. But I'm not too sure where to go anymore. I know I can pull out the groups, but it just looked really, I don't know.
Okay, so Luke is saying he is pulling stuff out of here, yes? Is that okay? What Luke is saying is similar to what we had over here. If I had the square root of 16x squared y cubed, he would start pulling stuff out.
They're all even numbers in the square.
Is that okay here?
Yeah.
Well, I'm asking you, look closely. Is this radicand the same as that radicand? No, why not? One is subtraction, one is multiplication, isn't it?
Notice that.
So while I applaud Luke's attempt, because he is trying to apply his previous knowledge, how we pull stuff out from under a radical, he is forgetting another piece of knowledge.
I'm changing it.
Every time we pull stuff out from under a radical, they're all multiplied, aren't they? Cannot do that here. So that approach is not the bestest. You could just calculate it because all of you are good. What is 8 squared? What is 10 squared? So isn't this 6,400? Minus, what's this? 1,600. So isn't that the square root of 4,800? What's this? Minus what? 900 is the square root of 2,700. Yes? Now, would you use those? Can I add those? I can't add those right now, can I, Aronica? What do I need to do? Simplify. I would make this 48 times 100. Then I would make it 3 times 16 times 100. Why? Okay. Why would I do... I'm not asking, I'm just asking why would I have followed this path? Because even if you didn't, you should be able to explain why I did. I took it apart and broke it down into perfect squares, yes? Okay, so even if you didn't follow my route, what would I do next? Because I want you guys to understand different ways of approaching the problem. What would I do next? Are there some square roots you see there? 16 has a square root, out comes a 4. What else? 100 has a square root, out comes a 10. And I left 3 under there to get 40 root 3. Agreed? What about this guy? I could have gone 27 times 100. Then what would I have done if I was following my own thinking? 3 times 9 times 100. What comes out? And 10. And what stayed under there? 30 root 3. Now what can I do?
Now you can add them until it's 70
Okay. Now, if you don't see these, what must you do? You must prime factor, yes? But do you really want to break down that?
Probably not.
No. So you need to recognize things like this. Is everybody cool? Everybody good?
Yeah.
Now, this question you really could only do if you remembered those perfect triangles, yes? But once you saw those perfect triangles, then it applies to this unit. Everybody with me? Yeah, yeah? Yeah, yeah, yeah. Now, your next page, if I am not mistaken, yes, it's mistaken. I'm just being funny. My wife always gives me a hard time for that too, Marley, because I say words that aren't real words, because a lot of people that don't really understand language will use words that sound smart, but they're not the right words, so they actually end up sounding not smart. For example, the word irregardless is not a word, but people use it all the time. Regardless. Regardless means without regard. Irregardless means without regard, which would mean with regard, which is the complete opposite of what you were trying to say.
So how would you say with regard then?
With regard. With regards to English, that is how you would speak. Regardless of what you think, irregardless is not a word. But irrelevant is a word, which is why people think irregardless is also a word.
Have you heard George Bush saying misunderestimate?
Yes.
It was really funny. He made up a word too.
Many people do in an attempt to sound intelligent. My son, just as a joke, as I said earlier, has been saying hoomst because he thinks it's funny. I know, and he knows, that it's not a real word. But if he says it in public, other people might think that he thinks it's a real word. That's why whenever I say irregardless, my wife gets mad at me. People are going to think you're dumb. I'm like, no, they won't. And then she says, but you're also making people think that irregardless is a word. And I say, irregardless. See why? Never mind. Hoomst would think that was a word. It's like the word flammable. Flammable is not a real word.
What's the actual word?
Inflammable. But because in usually means the opposite, people thought that inflammable meant it won't burn up. So they changed the word to flammable.
Why is flammable in the dictionary though?
It is now because all words were made up at some point.
Why didn't they say burnable?
All words were made up. Just like the word vape didn't exist when I was your age. Now it's a verb. One day soon, us who are we versing will be in the English language. Right? So, for example, Luke's rugby team is playing Bateman today. You guys say, who are we versing?
Do we say that?
Yes, they all do. Every single one of you. And I say nobody, because versing isn't a word. You know what I mean? I do. But that doesn't matter. All right.
So is that why a lot of English native speakers kind of get C2 language fluency?
I don't know.
Like in French, it's the same. Like my French teacher said, there's the C2 is the language proficiency that you native speakers struggle with.
Oh. I don't know. All right. Practice addition and subtraction of radicals. Is your page blank like mine? That seems odd.
Let's make some questions.
Let's make some questions.
Is that the book that can call us profit?
No. Some of the stuff is. I'm too lazy to think of any today. go.
Are you going to go to the US College Expo that we were talking about? Like last leadership class was talking about the US College Expo in Vancouver this weekend. US colleges and universities that like kind of present themselves. It's for visitors. It's Sunday, 4 p.m. to 7 p.m. And you can like there's a bunch of universities like Yale, Stanford, Harvard, all of those like Ivy League. But then there's also like UCLA, University of Michigan, University of Pennsylvania, and like a billion other universities.
Like this. So much.
And it took me quite a while to get through all of them.
There's 4. I am going to add more, but 4 is a lot of questions.
How would you do a 9?
6 on my page.
Yeah, and then so that is like so wrong on so many levels.
Yeah.
I'm going to have homework today.
Sure. No. Yeah.
Now, let me know like if you're interested in going. Because I'll go. I would
How do we square it if it's already
bus and schedule and all this stuff. Then they would pick me up in Langley. So
A squared plus B squared is C squared. How do you square it?
It's not that big, but the last bus leaves Langley at 6.
How am I thinking it again? Yeah.
You will probably not have homework. That is your work for adding and subtracting radicals.